Lesson 9-3 is all about multiplying and dividing rational expressions. Now these are going to be rational expressions, not equations. So these are not going to have an equal sign, it's just our two rational expressions, or again, they'll look like fractions. They have that bar across that we're multiplying or dividing together. So our first key concept we're going to be looking at is multiplying rational expressions. Now this is going to be just like multiplying fractions. And when you multiply fractions, you multiply numerators and denominators. You'll do the same thing for multiplying rational expressions. Now in the end, you can leave them as each of the factors together and then just cancel out or divide out any factors on top and on bottom. So in this example, you can see we've got x over 2x minus 3 is being multiplied by 3x cubed over 5. Numerators, x and 3x cubed, becomes 3x to the 4th. Denominators, 2x minus 3. We think of that, if we can't factor anything out, we think of that as being in parentheses. That's one whole piece. So it's this whole thing times 5. So we can leave it as the two factors, 5 and 2x minus 3. We just multiply everything together, and this would be our final answer. In the end, if you can, you will simplify, and I'll show you what that looks like in some of our examples. In our first example, we have 3 over 4x squared times 4 over 10x cubed. Well, when we simplify this out, put it all together, 3 and 4 are going to be on top. 4x squared, so 4 and an x squared right here, and 10 and x cubed, so 10 and x cubed, are all going to be on bottom. So this is how everything looks like as though it were all being multiplied together. Now, we can multiply them right away and then try to simplify, but right now where we have them in factors, this is probably the easiest to simplify things. Just cancel out the 4's right away. Or should I say we're dividing them out. We're dividing 4 out of the top and the bottom. 3 doesn't divide out of 10. Those are kind of reduced. And there's no x's on top, just the x's on bottom, so now we just have to put everything together. 3 on top, and 10 x to the 2 and x to the 3 makes x to the 5 on bottom. So 3 over 10x to the 5th. Example number 2, we've got 5n squared over 3 times 3n plus 7. So on top we have kind of just the one term. On bottom there are already two factors separated there. This is being multiplied by 5n squared times 3n plus 7. So again, two factors there, all over 5n squared. Now, if we were to spell this all out, it would look something like this. This 5n is right here, or 5n squared is 5 times n squared. This 5n squared is times another 5 times n squared. And this 3n plus 7 is right here. All of these terms, or all of these factors, are on bottom as we go here. Now from here you would say, okay, let's start canceling things out. 3n plus 7, 3n plus 7, a 5n squared and a 5n squared. And all we'd have left is 5n squared on top, 3 on bottom. Which would be true. We would have just, whoops, that'll not go, 5n squared over 3. To simplify this though, instead of having to spell out everything first, you can always cross-cancel factors as you're multiplying. Now you can cancel out right away and simplify, but you can also cross-cancel. So 5n squared and 5n squared, those ones cancel out. But this 3n plus 7 cancels out with this 3n plus 7. In the end, we can see there's nothing left over here. Everything canceled out, and just the 5n squared over 3. So in the end, we would have a 5n squared over 3. In some of our cases, you will need to factor first. You want to break things down into their smallest factors, which will help you start canceling things out. On our last one, we noticed that we can cross-cancel. So the first thing we should do right away is notice x minus 5, x minus 5. We can cancel those out. Now hopefully, if we factor this one, there will be an x minus 3. And we can cancel those out, and the only thing left would be that factor. So as we factor this, because this a value is 1, there's nothing in front of the x squared, we're just thinking, what are the factors of negative 12 that would add up to 1, this 1 from the middle here. Now those are going to be negative 3 and positive 4. So as we factor everything, that's going to be x minus 3 and x plus 4. Now when I wrote it all out, I didn't cross everything out first. So I'm going to go back and cross out this x minus 5 and x minus 5. This factored trinomial, if you need to AC factor it, go ahead and do so. But when the a is 1, all you need to check for is the factors of c that will add up to b, and those are going to be your two actual factors here, negative 3 and positive 4. So, in this case then, after we factored it, crossed out our x minus 5s, we do in fact have an x minus 3 and an x minus 3 to cross out. So the only thing left over is x plus 4. Now the question might be, what's on bottom then? Well, technically, if all these other ones cross out, there's a hidden times 1 on bottom. Because this times 1 is everything that was down here. So, technically, this could be considered an x plus 4 over 1. Anything over 1 is itself, though, so we can simply just say that it's x plus 4. Either one of these would be considered correct. But it's probably most simple just to say x plus 4. So this would be the simplified form. Example 4. Again, we're going to factor everything first. On the right side, the only thing we can factor is the greatest common factor. So we take 6 out of each of these. I'm going to cross this out right away. Take out 6, and we'd call it k minus 1. Same thing on bottom here. Take that out. We can take out a 6, and we'd leave k plus 5. This we need to factor. Again, because it is a trinomial and a is 1, our b is 1, and our c is negative 2, we just need to think, what are the factors of negative 2 that would add up to 1? In this case, that would be positive 2 and negative 1. Which means, oops, I think we can fit all this in there. There we go. When we factor it out, it's going to be k plus 2 and k minus 1. Positive 2, negative 1. So, as we spell everything out, there's a k plus 8 on top, times 6, times k minus 1, k plus 2, k minus 1, 6, and k plus 5. Everything from the bottom stayed on bottom, all of these on top became on top. Now again, our trick is to start canceling things out. 6, 6, k minus 1, k minus 1. So what we have left is this k plus 8 over k plus 2, k plus 5. So that would be our final answer. Remember, if you can, you should always factor first so you can start canceling things out. Our next concept to look over is dividing rational expressions. To divide by a fraction, you just multiply by the reciprocal. This is the same thing you're going to do when you're dividing with our rational expressions. What does that mean? It basically just means flip the second fraction and then call it multiplication. So here they used an example, a over b divided by c over d is the same as a over b times d over c. Notice that these two are flipped. This changed to multiplication. Okay, here's kind of a more exact example. They used actual things in there, and you'll see those in our examples as well. So, example 5. If we have 5a over 8 divided by 9 over 8a, we simply flip everything around. Not everything, just the second one, should I say. The second one gets changed to 8a on top over 9, and the middle piece is no longer divide, it's now multiply. Now, like before, we just cross things out, cross cancel, 8 and 8 go away, so we have 5 times a, 5a squared, all over 9. So it is in fact 5a squared over 9. And this is our simplified form. Example 6. Again, because it is division, first thing we have to do is flip everything around. I kept 15 times y squared on top. I kept 4 times x on bottom. That's what 4x means. It's no longer divide, it's multiply because we're switching these around. This denominator is now the numerator, 8 times x cubed. This numerator is now the denominator, 5 times y. Now, we can still cross cancel, but we just kind of have to do it in a simpler way. So instead of 4 canceling out with 4, we can take out 4 from the 8, which would leave 2. 4 times 2 is 8. So if you want, you can actually split it up into 8 is the same as 2 times 4, and we're crossing out the 4. If that makes more sense to you, do it that way. But all we're doing is crossing out the 4 and the 8 and leaving a 2 in place of the 8. We're going to do the same thing with 5. 15 is the same as 3 times 5, if you like to do it that way. Cross out 5, so we're leaving 3 in place of this 15. We have to do the same with our variables too. Y to the first power and y to the second power means we're crossing this out, and we're crossing this out, and it's now y to the first power on top. Okay, this goes back to Unit 4, just multiplying or simplifying down our monomials. Again, this is an x to the 1, this is an x to the 3. This one cancels out, and one of these x's goes away, so it's now x squared. So now, we've gotten rid of everything on bottom, so we'd call it a 1 on bottom, because it's all of this times 1. 3 times y, or y to the first, times 2 times x squared becomes 6x squared y all over 1. 3 times 2 is 6. Here's an x squared, here's a y. And again, because it's all over 1, you can simplify it to just 6x squared y. Example 7. This one we definitely want to make sure we are factoring first. Now we can do two different factorings here. This piece, we can take out a greatest common factor. I'm going to do that actually over here on the side. We'd take 3x out of both of those pieces, and we would leave x minus 10. Okay, so that's going to be this piece here. This one, because it's a trinomial, we have to look at our AC method, and A is 1. So again, our shortcut is we're thinking, what are the factors of positive 30 that would add up to negative 13? Well, that's going to be negative 3 and negative 10. So, to make our actual factors then, oops, let me get my parentheses in there. One's going to be x minus 10, one's going to be x minus 3. If we FOIL this out, it'll become this piece. So, this was on bottom. I'm going to take this and move this over here. This was on top. So, now that it's divided by, we need to remember to flip these as we make it multiplication. 4 over x minus 3 stays. This one now comes on top, 3 times x minus 10. This one now goes on top, x minus 3 and then x minus 10. Now we just multiply like before, making sure to cross cancel. X minus 3, x minus 3, x minus 10, x minus 10. What are the only things left over? Well, there's a 4 on top, and there's a 3 times x on bottom, so 4 over 3x. All right, our last example then. Again, make sure that we are factoring first. Also, as we work this one, watch out for opposite factors, and I'll show you what I mean. We saw that in one of our previous lessons, and those ones can be kind of tricky, but I'll show you what it looks like to have an opposite factor. So, 1 over 3 minus n divided by n minus 8 over n squared minus 10n plus 21. This piece needs to be factored because a is 1. We're just thinking, what are the factors of positive 21 that add to negative 10? That would be negative 3 and negative 7. So we will call those factors n minus 7 and n minus 3. So that's that factored piece. Because this is divided by, we need to make sure we flip everything. So these are now on top. This one is on bottom. So we have 1 over 3 minus n times n minus 3 times n minus 7 all over n minus 8. Now at first glance it might look like nothing is going to cancel here, but this is what we meant before by making sure that we cross cancel, or watch out for opposite factors. N minus 3 is on top, 3 minus n is on bottom. These are the exact opposite factors of each other. Now, if these were addition, so n plus 3 and 3 plus n, those ones are the same exact thing, because we have the commutative property of addition that says those are going to be the same exact thing. Because this is multiplication, or this is subtraction, sorry, because it's subtraction, they're not the same exact thing. So we have to change one of them by pulling out a negative 1. So we're going to change this one to negative 1 on the outside. Well, negative 1 times what would make a positive 3? This should be a negative 3. Negative 1 times what would make negative n? This should be a positive n. Notice now, negative 1 is on the outside. We have a negative 3 or a minus 3 with a positive n. This one also has positive n and a negative 3. So what we're going to do is simply rewrite this piece with a negative 1 on the outside times, we're going to flip these around, positive n minus 3. Now we can see that we can just cross out our n minus 3's in both cases. This is going to leave a negative 1 as one of our factors. So 1 times n minus 7 leaves n minus 7 on top. Negative 1 times n minus 8 leaves a negative 1 times n minus 8 on bottom. Now one thing to be careful of though, a negative factor, so pulling out this negative 1, can be applied to the numerator or the denominator or put to the front. And here's why. Negative 1 over 1, this is going to equal negative 1. If we flip it around though and put the negative on bottom, it's still the same thing. 1 over negative 1 is still negative 1. Well, let's say we applied that negative piece to the front of this whole thing. Negative 1 over 1. 1 over 1 is just 1. Negative that is a negative 1. They all mean the same thing. So this negative factor can either be put on top, put on bottom, or put out to the front. Normally, you'll see them written out front, so we will write it as negative n minus 7 over n minus 8. And that'll be it for our third video.